Hello guys, how are you doing today? In this video I'm going to talk about solenoid lock. Solenoid is an electromagnetic lock. It has different types, it has so many applications. So this is the tiny lock and it operates on the 5 volts, and it is operated on the 12 volts. Okay, let me give you a demonstration. This is a 12 volt battery. Negative terminal of the battery is connected with the black wire, and the red wire is connected with the 12 volt positive wire. So when the 12 volts is supplied, this latch goes inside the frame, and when I release the wire, then the latch comes back. So when I touch the wire, the latch goes inside. As soon as the wire remains touched with the terminal of the battery, due to electromagnetic field, the iron core remains energized and it stays inside the frame. As soon as I release it, then the latch comes back and comes out of this frame, and it loses the electromagnetic field, and soft iron core becomes de-energized. Okay, let's operate the 5 volts lock. The 5 volt lock is working on the same principle. I'm using the 5 volts charger. The red wire is connected with the positive side of the charger, and this is the negative side. As soon as I touch it, as long as these two wires remain touched, the iron core becomes energized. It retains its property, and this is all happening due to the electromagnetism principle. Okay, I'm going to explain solenoid in detail in this video. Alright, so let's get started. Let me tell you that how does a solenoid work, and actually how this lock is working. Inside this lock there is basically a solenoid. The solenoid is a piece of wire like this, but we are just making a coil by turning the wire like this. Is a long piece of wire wound in a shape of coil, so it becomes a solenoid. So this is called solenoid. Inside this solenoid we place a soft iron core. This is the soft iron core. You can also place the steel, but there is a problem with the steel, because steel becomes energized. It takes a long time. The steel takes a long time to be energized, and it takes a long time to be de-energized. So steel is not a ideal material inside the coil, so that's why we use soft iron core, because soft iron core becomes energized immediately and it gets de-energized immediately. This is the property of soft iron. This iron is the ferromagnetic material. It becomes a temporary magnet as soon as it is placed in the magnetic field. So when the current, as we are supplying the current from the battery, so I am drawing a battery over here. This is the battery. This is a positive terminal, this is a negative terminal. The current starts flowing from here, is going like this, straight up, and then like this, and then like this, and then like this, and then like this, and then it's coming back to the negative terminal. So we are using the right hand grip rule. This is the right hand, and this arrow is going up, so we will grip it like this. The thumb is giving you the north pole. So as you are gripping like this, right hand grip rule, the thumb will point out towards the north pole. So here will be a north pole, and here will be a south pole, and you already know that the magnetic field starts from north pole and ends on the south pole, and going towards the south pole like this. Another field like this. Outside there is a non-uniform magnetic field, and inside there is a uniform, stronger magnetic field. So this magnetic field is stronger inside like this. Uniform magnetic field is created inside the coil, and non-uniform magnetic field is created outside the coil. Inside the coil there's a uniform, stronger magnetic field, and outside there's a weaker magnetic field. So what happens? This magnetic field retains itself as long as the current is there. If you just remove this power supply from here, this magnetic property disappears. That's why we call it electromagnet. What do you mean by electromagnet? Electromagnet means if electricity is supplied from the battery, this property of magnetism retains. But if this electric source disappears, this magnetic property disappears. That's why it is called electromagnet. This is not like a permanent magnet, because you know that this is a permanent magnet. In the permanent magnet, one end is the north and one is the south, and throughout its life throughout its life, this property is retained. It is not dependent on current. But here, electromagnet and permanent magnet, there is a huge difference, because here this magnetism property is dependent on current, and here magnetism is not dependent on current. This property is maintained throughout its life, and this property is totally dependent on electrical energy. So basically what happens, we place, as I told you that a stronger magnetic field exists inside the coil, so we place some material here, some metal over here, and that ideal metal is always soft iron core. Why don't we use steel inside this? Because steel takes longer time to be energized, and it takes longer time to be de-energized. On the other hand, soft iron core becomes energized immediately. As soon as the current is applied, it becomes energized, and as soon as the current is disconnected, it becomes de-energized. I am showing this soft iron core using this blue color so that you can easily understand. This is the soft iron core we have used inside the coil. And why we have used this soft iron inside this? Because this core increases the induction. The more magnetic field is concentrated inside the coil because of this core. That's why we are using soft iron core instead of air core, because if there's air inside, the magnetic field is not fully concentrated inside the solenoid, and when we use the iron core, the more and more magnetic field, and you can say the induction property increases because of this, and more flux is concentrated inside the coil. Now let's apply the current. Let's see what happens when DC power source is connected. I am supplying the DC current over here, DC power source. When DC power source is connected, so see what happens. This core or latch is going inside as long as the current is supplied. As I remove the battery, it comes back. If I touch the wire, it goes inside. If I remove the wire, it comes back. All right. So due to the supply, basically it is working on the current, on the electromagnetism property. When current is supplied, it goes inside, right? So what happens? The battery is connected over here, DC source is connected over here. As soon as the current starts flowing, so it will move. All right. Why it will move? Because it will become a magnet, and the north pole will push the north pole of the core. So opposite poles repel each other, and it will go inside. And when the opposite poles, when the supply is removed, all right, so it loses its magnetic property and it comes back. All right, so I have connected a button with this. When you press the button, the latch goes inside. And it can also be used with the access control system. This is the circuit of access control system, and this is the access card. If any person wants to enter some premises, so outside the door he will see this card reader, and if this person has access, so he would be having this card. As soon as he touches the card like this door would automatically open. So these locks have so many applications in the security access control systems. It can also be used as a automotive doors with face recognition system. If any person comes in front of the camera and that person is allowed to come inside, like then what happens? The face recognition system recognizes the face and matches with the saved images, and triggers the lock and opens the door for the person. So this is it for today. I hope that you have got a lot of knowledge about solenoid locks, how these locks works, and what is the principle behind this. So I hope that you like this video. Don't forget to subscribe and like and share the video. I will see you in the next video. Till then, bye bye.